All right, let's take a look at this next one. And it says we've got a gradient. I'm going to see if I can find a sharper pencil here. That one, that looks good. Here we go. So I've got a gradient function as this. I've got a coordinate, the minimum turning point of the curve is 10. So let's just roughly draw how that's going to look. So I've got my x and y axes here, but I've got a parabola, not a parabola, sorry. I'm going to have a cubic function, and the minimum turning point is going to be 10, which means if it's looking like this bit here is going to be x comma 10 for this point here, yeah? We just don't know what the x is. But we can find the x of turning points. Well, let's find out what the x values will be, because I can take this here, this is my gradient function. So I've got dy dx is equal to 6x squared minus 12x. Make it equal to 0, and suddenly the two x values of the turning points are going to reveal themselves. One's here, one's here. What are those two? So let's see what this is going to be. 6x squared minus 12x. I can go ahead and factorize this. So 0 is equal to, it's going to be 6x, which is going to be x minus 2. So either this is 0 or this is 0. If this is 0, then either x is 0, because 6 times 0 is 0, or x is equal to 2. So this value here must be a 2, and this value here must be a 0. So that's roughly what it's going to look like, yeah? So I've got this value here is going to be 2 comma negative 10. So my actual point I'm going to have, my reference point, is 2 comma 10. And that's the minimum point. Okay, that's this point way up here above the x-axis here. So I've got an x and a y here. This is going to be going somewhere here, but the minimum point thing is going to head down and go like this and head back up, and that's going to be something else over here, and it's going to do this, maybe somewhere over there or there, who knows. But this point here, this is the x value there is a 2. So let's go ahead now, and the y, of course, is a 10. This is a 10 here, so 10 there. Okay, right. So let's go ahead and write all that in. So let's first of all anti-differentiate that. So we've got y is equal to 6x squared, make that a 3, sorry, on 3, minus 12x 2 on 2, plus c. Let's tidy that up. So y is equal to 2x cubed minus, that's going to be 6x squared plus c. Now let's plonk in my 10 and my 2. So y is 10 and x is going to equal to 2. So I might just rewrite that slightly. So it's going to be 2 times 2 cubed minus 6 times 2 squared plus c. And so where do we land there? So 10 is equal to, well, 2 cubed is 8, 2 8s are 16, minus 2 squared is 4, 6 4s are 24, plus c. 16 minus 24 is 8, so 10 is equal to negative 8 plus c. So that means that c is going to equal, I'm going to add 8 to both sides, plus 8 is equal to 18. So now I can write my equation, so therefore equation is, and I'm going to write this one here, this is what I'm writing here, and this time I'm just going to add in the c value on the end, so it's going to y is equal to 2x squared minus 6x, sorry, cubed, what am I doing? Cubed, cracky, 6x squared plus c is plus 18, and that should be good. Here's my answer there. Hope that makes sense.